everyone. This is Maurizio, editor-in-chief of Power Electronics News and Embedded.com. I am at Electronica, showing in Munich. And I have the pleasure to be here together with Bart Placklé, Vice President of Automotive at imec. Hi, Mark. Thanks a lot for being here.
True pleasure. It's a really right time, so we're very happy to be here and to talk about autonomous vehicles and what electronics does in that.
Sure. So before starting, tell us more about you. Please introduce yourself, your activity, and your company.
Yeah. So I'm an automotive shiphead. Worked for Automotive 20 years. I was the CTO for Intel. Then last job I did for Intel was being the CTO for the robotaxi. And then already 2 years almost I'm working for imec, and it's really driving the next generation of vehicle architecture for both autonomous and infotainment to see like where can the technology bring the automotive industry.
So great. So let's talk about electric vehicle. Let's talk about electric vehicle platform, semiconductor challenges. So the shift to high performance electric vehicle, autonomous vehicle, alongside the semiconductor shortages. So all of these are is putting pressure to the automotive industry. So how you are working? How is imec addressing these challenges? Maybe talking in particular about supply chain.
Yeah, before talking about supply chain, I think it's fair to say that right now is probably the most disruptive period in the history of automotive. We used to see how internal combustion engines would evolve. Then we used to see how electrification was going. Now we have the geopolitical, and now we are also totally re-architecting the car to something which was horsepower and was drivetrain to now we have something which is the DNA of the car's software and hardware. And that is really totally disrupting the supply chain, because no longer is it a value that you can bend metal. Now it's really, can you build an ICT platform? And a lot of OEMs are really not capable or ready to do that. And even worse, if you now go into trends of full autonomous driving, you're building supercomputers, and there are not too many people that can really manage to build a supercomputer, to update a supercomputer. It's a total new skill set you need for that, and totally new electronics you need for that.
So let's talk about sustainability. So there is a growing pressure on the automotive industry to reduce carbon footprint. So how you are applying sustainability in your technology, in your how you are contributing in terms of greener technology?
Yeah, it was interesting to know. So when we have discussions about sustainability with tier one OEMs, basically the whole supply chain, it's pretty interesting that they typically know perfectly like what your CO2 footprint for welding, for bending your metal, etc. That's something that they've been doing for the last 100 years. But if you then ask them like, okay, what is the CO2 footprint for your high performance compute or for your sensors, they really don't know. So we educate and we help them to really disaggregate those technology platforms and then really try to educate them where they can optimize their manufacturing process, but also throughout the life cycle of the vehicle, where to take care of and how to change the architecture to have a minimum CO2 footprint. But it's very interesting that where you expect the most CO2 footprint, that's what they have under control. Electronics, it's a big gap right now, and that's where we're helping.
Thank you. So let's talk about chiplets. So yeah, so chiplets are revolutionizing automotive car manufacturing with the goal to offer modular solutions compared to traditional. So can you explain how imec's automotive chiplet program is advancing chiplet integration in vehicle systems, especially talking about AI and vehicle safety, and also in terms of standard. So which are the main challenges to define a sort of a standard, if we can define a sort of standard for chiplets?
Yeah, let me first start with the reason why we need chiplets. So Moore's law, Gordon Moore, he predicted like 6 decades ago that you have transistor doubling every 18 to 2 years. But what's very interesting is that also 6 decades ago, he predicted that there would become a time that your feature size becomes so small that it's become very, very difficult to further increase the performance. And right now we are at that border point that it's always it's getting more and more difficult. And we're now getting to a border or a transition time where for larger systems like high performance compute, which you need for the in-cabin or ADAS, where it becomes more beneficial to start chopping up your architecture in smaller pieces so you have a higher yield. But by doing that chopping, you also have the benefits that you can say, okay, now my neural network accelerator can be the most optimal process node. My I/O that doesn't scale well, I put it on a different process node. So you can really optimize your system design. And of course, once you have chiplets, you can start building scalable products. You can have more or less chiplets, and that's how you build your portfolio. So that's really why I think the industry outside automotive already, everything which high performance already transitioned into chiplets. And now is the time, because we're getting similar performance levels for autonomous and in-cabin with their new, the large language models, we're getting into a similar level. So we now need to have similar principles, but no one has validated, no one can tell you today that this is how a chiplet architecture will survive in automotive. It has to be there 10, 15 years, 130,000 hours, and that's exactly what we are doing at imec. We are trying to bring the high performance compute chiplet technology down to automotive, making sure it works. But that's only the first step. The second step to your question is like, how can we make sure that if we have all these chip building blocks, that they work to each other? And that's really where standardization is a must. There's already a first level for die to die. There's already a standardization which is called UCIe. But that only allows the bits to talk to each other. UCIe doesn't specify how each chiplet should behave, which language they should use, how you bring them up, how you load firmware, how they behave from a functional safety. None of that is being done. And that's the second part of our imec program, our automotive chiplet program, is really looking at the overall architecture and standardizing those higher level protocols. So one part of our program is making sure it will survive, its quality, the reliability, its cost effectiveness. And then the second part is making sure that we have an interoperable chiplet ecosystem with the right standardization from the lower level to the higher application level.
So to ensure interoperability and seamless integration.
You really want to get into a stage where the chiplets will be designed independent of each other, and then at a very late point you say, okay, this is the product I want, now I'm going to source these chiplets, put them on a package. And 10 years ago you would source ASICs or chips and you put them on the PCB. That's the level of standardization you need to get get it on a package.
So in automotive, I see a moving away from traditional tier one to a new models that working with very close with semiconductor companies. So what changes do you see in this regard, in these new models, if we can define new models, and how also imec would facilitate these new models?
So that's what I call the pendulum swing. So in the past, you don't have to go too far back. The OEM set the high-level specification, like this is what my system needs to do, and then typically the tier one, they would then take those requirements and they talk then to the tier two, the chip vendors, and they build your system. Typically, a lot of those systems look alike because you only had a handful of components, so a lot of those platforms looked the same. Then you had the disruptors that said like, no, we want to do the whole architecture ourselves. Some of the disruptors said like, Tesla is an example of it, I'm going to build my own supercomputer I'm going to do my own silicon. But clearly then you need tons of volume to justify it, to have a return on investment. So a lot of other disruptors tried to follow that and said, well, that's not affordable. So we go from one side to totally other, and now we come into chiplets. And what's the beauty of chiplets? Now, for the first time, you can build differentiating OEM products without having to incur the full development cost. Because if you are an OEM and say, I want to differentiate on my accelerator, you can reuse a chiplet for the CPU, you can reuse a chiplet for the memory chassis, for another accelerator, but you really want to have your differentiating part, which is the driving, which is the inference, and this is where you just make your own chiplet or together with the ecosystem, and then you put it on a package. So for the first time, OEMs can have a fully differentiating product without having to pay the billion of development cost that they have to incur otherwise.
Great. So great point. So in conclusion, Bart, so just looking forward, so just a final remark about what's future in terms of automotive, considering the different challenges, the different topics that we also discussed it in terms of electric vehicles, in terms of smart city, electrification, autonomous vehicles. So how do you see these trends shaping imec's roadmap and also the different priorities in the research team?
So yeah, on a short term, it's really making sure. So we need the performance. For the performance, we need to go to chiplets. So the first priority is making sure that chiplets survive, that we have the right interconnect technology, that we come up with an interconnect technology that is affordable, and basically that will survive the longer term mission profile. So that's priority number one. Priority number two is making sure that we create a scalable ecosystem. This means that we need to have standardization. And all these things we're doing to get into start of production by 2030. So we just started a program where we're doing the nuts and bolts, so the basic research. Next year we're planning to do a reference design, and that reference design should then be the stepping stone for the OEMs, for the tier ones to start building their architectures for 2030.
Thanks a lot, Bart. Thank you for this opportunity. It's been a pleasure, and have a good day at Electronica. Thanks.
My pleasure. So.